Alright. Are you guys able to see?
Yes.
Okay, thank you. Alright. Well, okay. So, last week we started up looking at the ordinal equilibrium of our consumer and a brief application. Now, a couple of things we saw to begin with was the objective function of the consumer, which is always to maximize their satisfaction. But then in this case, we made sure to look at the fact that the consumer always has to consider their budget. They always have to consider the amount of money they can spend to have the goods that they want. So whatever good they choose to buy has to be within their budget. And so that's what we call the budgetary constraint. We saw the formula for budgetary constraint, which is this one here, and also the formula that allows us to show it on a graph. And then we saw that this particular formula only has two coordinates. In one case, x is equal to 0, and y will be equal to the revenue of our consumer over the price of the good y. And in the case where y is equal to 0, x will be equal to the revenue of our consumer over the price of the good x. And so we also showed exactly what this line looks like on our graph. We looked at the optimal combination, which coincides with the point of tangents between our budget line and the most possible elevated curve of indifference, which in this case is our point E right here. This is also called the point of equilibrium. This is the point where our consumer gets the most satisfaction while taking into consideration the amount of money they can spend. We also looked at what else this implies. Voila. In this case, the formula for taux marginal de substitution is px over py, which is also equal to the derivative of y and y in terms of x, or x in terms of y, which we will see as we go on. Naomi, you are welcome. We're just going over our last class and then we'll begin. Okay, so what else did we look at? We look at how to apply the second law of Gauss to ordinal equilibrium. And so we saw this equality here, which is the marginal utility of x of marginal utility of y is equal to the price of x over the price of y, or umx over px is equal to umy over py. It means the same thing. And we saw what these particular ratios mean. Px over py is le taux de change du marché. We mentioned that this is something that is objective. It's something that cannot be changed. It's standard for the consumer and for the producer. And we saw also umx over umy, which is le taux de change subjectif, which is unique to our consumer. It depends on whatever the consumer wants. And then we got into our application. So are we together so far?
Yes.
Okay, thank you. All right. So in our thank you. In our application, we saw how to apply, how to find the best combination of goods, taking into consideration the budget of our consumer by using the method of the marginal rate of substitution. So we had this question here, and it's shown throughout this PowerPoint, but we will use the question that I gave you to look at it in more detail. But for as long as you want to solve this question, these particular steps here are the best guide that you could use to solve any question of this nature. So having gone over briefly what we did, we can go on to today's lesson, beginning with our question. Alright, so I'll ask someone to read. First of all, are you able to see everything here clearly? Can everyone see the words, the numbers, the equation? Is everything clear? Or should I increase it a bit?
It's clear.
Okay. So could someone read the question for us before I begin to explain? Anyone? You can unmute and read. Anyone? Shall I don't feel shy, it's just French. Let's see. I'll give someone a chance to volunteer before I pick someone myself. Who's going to read?
Okay, I can try.
Okay, thank you, Xavier. You can go ahead.
Soit un consommateur raisonnable dans la fraction d'activité et de la forme U is equal to 12xy minus 0.5xy squared minus 0.5y squared, où x est désigné des quantités consommées de viande x et y. Les prix de ces viandes sont respectivement px égale 100 dirhams et puis y égale 100 dirhams, sachant que le revenu, le consommateur est revenu égal à 6 000 dirhams. 6 000 dirhams. Calculer la combinaison optimale des biens X et Y à l'indice d'utilité totale maximum.
Okay, thank you very much. Well done. Okay, so the important things to consider in the question we have before us, first of all, is the function of utility. In this case, u is equal to 12xy minus 0.5 x squared minus 0.5y squared. So in the document I sent you, there was a particular error where it wasn't x squared, it was x2, and it wasn't y squared, it was y2, which may or may not give the same result sometimes, but it's better. Though I don't know who handed in, but the question came out like this, so that was fine. I don't know how you came to that conclusion, but that was pretty impressive. Otherwise, it may or may not give you the same answer, but it's better if you can see what it's really supposed to be. So the first thing to consider is the function of utility. In the previous lesson, I showed you how you can find the answer to this question using the function of utility, but I showed you also a simpler method where you just use the prices of the goods to find your ratio, which is pretty similar to what we saw in the first section of our course. But seeing, even though the question had an error, I noticed that most of you had a good grasp on that particular method, so that was good, and you should keep that one in mind. But for this lesson, I'd want you to pay more attention to how we'll find the answer using the function of utility, because it's more likely that you have this one in the exam than the previous one. But if you know either of the two, it's easy for you to confirm if what you've done is correct. So yeah, we also now have to consider the prices of our goods. We see that it's both 100 dirham, so obviously our ratio will come to 1/1, and then the revenue is 6,000 dirham. So our question is asking us to find the optimal combination and also the indice d'utilité. Basically, when it says indice d'utilité, it's basically asking you to find the total utility. So when you find your value for x and y, replace it in this formula and find what u is. Donc on commence. The first step. This is the step that I showed you previously, where you just compare the prices and have a ratio. So in this case, our prices were 100 and 100, and it gave us the ratio of 1:1 or 1/1. So what we'll do is we'll take our y over x here, equate it to our 1/1, find our ratio. When you cross multiply, you have x is equal to y, and then we'll begin to replace. So are we together so far?
Yes.
Yes.
Okay, thank you. Alright, so our second step is that we'll take this little equation that we've made here, and we'll now come and replace it in our formula for budgetary constraint or for revenue. So it works either way. You could either replace, since they're equal in this case, you could replace x with y or y with x. It would give you the same answer. For example, if in this case you weren't going to replace with y, say you remained with x, and you put x on this side as well, because y is equal to x, you'd still have the same thing. But that only works for this particular case, so it's not something I would recommend. Basically, just understand how to replace your egality in your equation and you'll be okay. So now, having added these two, you have 200y. When you divide both sides by 200, you come to the point of 30. Y is equal to 30. And if y is equal to 30, then x is also equal to 30, because they go through the same thing. And so what you do at that point is you take these values and replace them again in your formula for revenue, and make sure that it gives you 6,000. In this case it does. So for this part, you're pretty much done. This is the simpler method of finding this. Is that okay so far?
Yes.
Okay. Feel free to stop me anywhere if you need any clarification. So now this is where we had the issue, because when I gave you guys this question, the answer that you found was 10,740, if I'm not mistaken. But once you take the corrected version of the formula, it should give you 9,990. So to confirm this, I'd like for anyone who has a calculator with them to just take it quickly and input this formula exactly. That is 12 times 30 times 30 minus 0.5 times 30 squared minus 0.5 times 30 squared. It should give you 9,900. So the peculiar thing about this function, if you don't input it correctly into your calculator, you might get the wrong answer, because of the calculator is built to follow BODMAS. So it depends on what the priorities are. Take, for example, if you were to say 12 times 30, find the answer, times 30, minus 0.5 times 30, then you square it, minus 0.5 times 30, you find the answer, then you square it, it might give you a different answer. So usually what's best is you first replace your values into your formula here, and then take exactly how it looks in your formula and put it into your calculator, and you should find the correct answer. Anyone with a calculator, have you confirmed if this is correct?
Yes, it is.
Okay.
Yes.
Alright, thank you. So yeah, for those who submitted the work, just take note of this part. This is the correct answer. Your replacements were fine, of course, the error was my fault. But yes, this is the correct answer for our question. If everything is okay here, we'll move to the next point, which is showing us exactly how to find the same answer, but using the formula for total utility. Remember to take very good note of this one, because it will most likely come in your exams. The one that's before, it's kind of easy, they might not bring it, but this one they should bring it. So let me just increase this a bit. Let's say 22. Is everyone able to see?
Yeah.
Okay, thank you. Alex, how much time do I have?
4 minutes.
4 minutes. Alright, so within 4 minutes we'll just try to go over this first part. Alright, so when trying to find the optimal combination using the total utility formula, we'll be using a case of classic differentiation. I don't know how well you guys remember differentiation from high school, but it's a basic rule that we will apply here. So from the previous lesson, we learned that in this case, the utilité marginale of x is equal to u prime de x. Basically, you differentiate this formula in terms of x. And when you differentiate this formula in terms of x, the answer is equal to y. In the same way, when you differentiate this formula in terms of y, the answer is equal to x. The same value is equal to your utilité marginale. But for now, you can forget these two parts in front, the umx and the umy. We'll just focus on the part that follows. U prime de x is equal to y and u prime de y is equal to x. So what we'll do in this case, we'll take u prime of x and we'll differentiate our formula in terms of x. So when you come back to our formula here, you find that since we're differentiating in terms of x, x is the only value that matters so much here. You see that in this first part, x is to the power 1. So what you do is you bring down that power and it will come here. And then what you remain with is x to the power 1 minus 1, which will give you 0, which is when a value is to the power 0, it's equal to 1. So let me just input that there. Script 1. So we'll say x here, remove this one, x to the power 1 minus 1, which is equal to 0. And then x to the power 0 is 1. What you do is you say that very one multiplied by y gives you your answer. So that's why you have this 12y here. If it was a case where we didn't have an x in this part of the formula, everything else would disappear. In the same way, you take this here, you bring the 2 down. I don't know how necessary this is, because for those who may remember how to differentiate, this won't help you much, but we'll go at maybe for the sake of those who might not remember. Voila. So, like I said before, when differentiating in terms of x, x is the only value that really matters in this case. So you bring down this 2, it comes here. When you multiply 2 by 0.5, it will become 1. And then 2 minus 1 is 1. X to the power 1 is just x. And that's why you have your x here. So coming back, 1 times 12 is 12. X to the power 0 is 1. And 1 times y is just y. And so you have 12y. When you come here, 2 times 0.5, the 2 coming from x, 2 times 0.5 is 1. And then x to the power 1, because it's 2 minus 1, is just x. And so you have 1 times x, which gives you this here. When you come to the last part of the formula, you find that there's no x here. And since x is the only value that matters, it will be completely eliminated. There's no way for it to remain because there's no x. I'm assuming my time has elapsed.
Yes.
Okay. So before we go on our break, is this part clear to some degree? Just the differentiation.
It's not really clear.
Alright. So to be the first thing that we come back to. What I would advise is, after the class, go and watch some videos on basic differentiation. It will help you. In as much as I try to explain these calculations, I can do them, but explaining them is not my strong suit. But there are a lot of videos that would help you. Just basic differentiation. If you can apply basic differentiation, then this part won't be hard for you. Alright, so we'll go on our break. Alex, you tell me when to come back. Thank you. Alright, so before I come back to this point, there's a couple of people who were able to come to this conclusion in terms of this question. So let me ask, does anyone remember how to apply basic differentiation?
Yes.
Okay. Would you be comfortable with attempting to explain this to your friends? No?
Yeah, yes, I can.
Okay. Yeah, then go ahead, let me mute my microphone, and then I'll come in wherever I may be needed. Wow. You can go ahead.
All right. Yes. The u total is equals to 4x times y minus 0.5 x squared minus 0.5 y squared. So differentiation is like you multiply the base, then you reduce the power by 1. So that's the first step. You multiply the power times the base, then reduce the power by 1. So it should be 1 times 12, then x, if it doesn't, they didn't indicate 10 power, which means there is 1. So it will be x power 1 minus 1. And x power 1 minus 1 is 0, which means n but the power 0 is 1. Then y minus 0.5 x squared, it will be 2. That square times the base, which is 0.5, then that power will be reduced by 1, which is 2 minus 1. Then you don't have to, you do away with the last one. It's more like a constant. I don't know how I can explain it, because we are only concerned with the x. So it will be total heat is equals to 12y y minus x. Utility prime x is equals to 12y minus x. That's how they got to that equation you see there.
Thank you, Alex. Yeah, I don't know if it's made sense for everyone.
It's clear.
Okay. Alright. Thank you. And thank you very much, Alex. So, what you'll do next is you'll apply the same thing, the very same method that he's applied to x. In this case, it will be in terms of y. So let me just correct this here. This is supposed to be y. Voila. So in this case, you will only be concerned with y. I'll increase this to voila. And you go about the same method. I don't know how necessary it may be to explain that entire point. Let me just bring this back here. Okay, there we go. Oh, if we need to come back to this application, we'll come back, there's no problem. But yeah. So this is your first step. Your first step is to differentiate in terms of x and of y and it's these formulas that you will use then to find your values for x and for y. This therefore takes us to our next step. So there's this entire formula here that was given in the previous lesson, where we said that the derivative of y in terms of x, or in other cases in x in terms of y, is equal to the marginal utility of x, or marginal utility of y is equal to the price of x over the price of y. So we've already done our derivatives, which are 12y minus x and 12x minus y, which is the very same thing as the marginal utility. Like we said here, when you derive in terms of x, it gives you the marginal utility of x. When you derive in terms of y, it gives you the marginal utility of y, which is also equal to x and equal to y. So just take note of this part here, and it brings us to this point. So you basically forget about this entire point here, just put it aside for a moment and focus on this part of the formula. 100 over 100 is the same as 1 over 1, and therefore you have 12y minus x is equal to 1 over 12x minus y is equal to 1. So what you do is you cross multiply, and it will bring you to this point, and you do the usual putting like terms together. You take this y here and take it this side, which will give you 12y plus y, and you take this x and take it to the other side, which will give you 12x plus x, which gives you 13y over 13x. When you divide both sides by 13, it gives you y over x, which is the same equality we had previously when we used the first point, x is equal to y. And so basically what you do is the same thing. Once you found that equality, you bring it back and apply it to the budgetary constraint formula, which will bring you to this point until you find y is equal to 30 and x is equal to 30. So this is just another way of finding the very same answer. And even when you come to apply it here, it gives you the very same answer because it's just the same thing. So like I said previously, I would want you to pay more attention to this formula for now, because the previous one, which is simpler, you won't have it as much in your examinations. It's good for you to understand it so you can apply it in different cases, but mostly in your exams you have this method here. Are we together? Do I need to go over this part again?
Yeah, so like the answer is y is equal to x, but like we don't have the coordinates, so how are we going to know the combination?
Right, so like I said, that brings us back to our step 2, because it's the same question we were dealing with in this case, where we had x is equal to y. So you come back to our step 2, you get your revenue formula. On revenue, our revenue is equal to 6,000 dirham, the price of x is 100, and the price of y is 100. So now you found out that x and y are equal. So what you do is, where there's x, you put y. Or if you want, where there's y, you put x. Like I said previously, you could change this. It can be 100x plus 100x. It will give you the same answer. And so that's what we've done here. Once you find this, when you divide 200, which you found here, into 200 here and 6,000 here, your answer is 30. And since x and y are equal, x is also equal to 30. And so what you found is you've actually found your optimal combination. You found that the quantity that you want to consume of x and of y that fits within your budget is 30 for both. And that's where we have our verification in this case. That shows us when you replace the 30 into this formula here, it does actually give you 6,000. So in terms of finding your coordinates, what you have to do is get this equality, which is x is equal to y, and apply it into your budgetary constraint formula, and that will help you find the values of x and of y. Is that okay?
So as you now have to use both methods.
It depends on the question. In class usually you use the first method, I should say. It will be the first one you learn, I think, because it's easier. But in examinations, most likely you will use the second method of using the total utility formula. So starting from step 4 is its own completely different method, which you'll use mostly in your examinations. I hope that answers the question.
Yes, and the last method, the formula, is it not just proving that x is equal to y or y is equal to x?
Yes, exactly. They both lead you to the same point. Yeah?
Yes, thanks.
Okay, you're welcome. So yeah, that's pretty much how this part ends. I've been interacting with mostly 2 to 3 people so far. I don't know how clear this is for everyone else, because it's very easy for me to be interacting with a couple of people while the others kind of remain behind. So I want to know if everyone is okay on this point. If possible.
I guess clear on something, just a clarity. Last time when we started, we were doing the methods TMS, right? So this step 4 is the second method that you're talking about?
No, we're still under TMS.
Oh, okay, alright.
Yeah. So, yeah, let me just expand that a bit. So both of the methods we've seen are under TMS, except one is focused on using your prices to find the ratio, and then the other one is focused on using the derivatives. Let me just come back up to step 1. So in this case, the first method, you use your prices 100 over 100, which is 1 over 1, and you equate them to y over x. And once you do this, you will easily find the value x is equal to y. That's the easy part. But the second formula, you will now use your total utility formula to come to the same conclusion of x is equal to y or y is equal to x by using derivatives. So it's all under TMS, just different methods of going about it, like you're focusing on different things. The first part, the focus is the price, and then the second part, the focus is the derivatives of the formula of total utility. I hope that clarifies everything.
Yes.
Yes, but I want to ask something. Is there any question that requires the second method? It cannot work with the first one, it only works with the second one, or it's nothing like that?
I don't think that's possible. Yeah, because generally the ratio that you find for your prices, once equated to y over x, should give you the same thing. If it gives you something different, then there's a problem. Then there should be a problem there. So it works. Go ahead.
Yeah, so we've managed to find the combination, and we've also managed to find the total utility. But when does the TMS now come in? When does it come in?
TMS is what you use to find this ratio here. It's what you use to find 12y over x over 12x minus y. Basically, it just helps you to come to this conclusion of y is equal to x. It's just a part of the process.
Yes, thanks.
Okay. Any more questions?
Last question. in an exam, you said the question is going to specify using the TMS formula, but use the formula for finding
differentiation.
utility and
In that case, let me say that your professor will specify. Yeah. I think there's a case where it will show which one exactly to use. Let me just find. There's one question I intend to give you today at the end of the lesson, in which you will use that method. But generally, I think your professors would advise. They will tell you exactly what to do, which one to use. This will be in class, of course. They'll tell you that you can use either, but I prefer that you use this one. But let me just see if there's anything that specifies. Where is it? Okay. Oh, by the way, for those who will end up at the ENCG or FES, most of the questions that, no, not even most, all of the questions that I've given you, they are what we call TDs, travaux dirigés. So I would advise you to keep the answers safely so that when you come here, you won't really have to struggle much with your professors. You can even go and shine some in class because you already have the answers to the TDs that you learn. Yeah, so let's see. Okay, so this is the question that I gave you. As you can see, it doesn't really specify which method that you will use. So let's say that your professors will advise you on which one exactly to use, which version of the TMS method to use, whether you're differentiating, whether you're using the prices, or the other formula, which we'll see later on today. Let me see if I can find some past papers just to confirm. Is there a message? 3 minutes. Okay. Thank you, Alex. Okay. Vérifier l'égalité au niveau d'équilibre. Formula here. Okay. So here's a question here. Let's see. Number 2. It says, on suppose que le consommateur exprime son niveau de satisfaction à travers la fonction d'utilité suivante, which is the one we have here. I mentioned in a previous class that every question of this type will have a different utility formula. So in this case, we have this one, 2 over 3x to the power 2 over 3 times 1 over 3 y to the power 1 over 3. So it's an entirely different utility formula. And then it says calculer les quantités de x et y qui maximisent la satisfaction du consommateur en utilisant la méthode de Lagrange. We haven't looked at this one yet. It is the one we look at in the next part of our lesson. So usually they'll either tell you TMS, which is what we looked at, or Lagrange. So for TMS, it depends on your professor. If your prof tells you that you can use the one for using the ratio of price, you can use it. Or if he tells you to use the one for differentiating, use that. So I'll say just wait for what they'll tell you. But if they want you to use Lagrange, which is the one we'll learn, they will specify. I hope that answers the question.
Yes.
Okay.
But have we been given the prices for X and Y and the error for what X and Y in this question?
Yes, you have. The revenue is on top here. ARA is 30 dirham. And then the price of these things are given in question 1. The price of X is, Y rather, is 2 dirham. And the price of X is 1 dirham. Yeah. So you've been given. Yeah. So yeah, I will make these things available to you at the end of our lessons. I'll send you. You already have the entire course here. I'll send you the TD. Of course, you won't have to look at everything because we won't look at every question that's in the TD because it's different sections. But I'll send it to you, Kamem, and then I'll send you also this particular past paper. Just for you to look at. I don't think there's much that you can answer here at the moment, but you just look at it and see whatever makes sense. Yeah. This part here, exercise 2, you won't have to look at it because we won't learn it in our courses. It's the second chapter of our note, which is producteur, which we won't learn. And then there's marché, which we also won't learn. But on this second part, we have elasticity, which is the last section of our course. Voila. Okay. So yeah, getting back to the lesson, I'm assuming my time has elapsed. Alex, has my time elapsed?
Yes.
Yes.
Okay. Alright, so we'll go on our break now, come back in 5 minutes and begin the next session, the final session of today's lesson. While you're on your break, just think over what we've looked at in this case, and if you have any more questions, feel free to stop me.
can start, Manta.
Thank you. Alright. Just come back here. Okay. So the second method of finding the optimal combination is what we call the Lagrangian method, and we use what is called the Le Multiplicateur de Lagrange. In this case, you'll be doing a good amount of differentiation also. It's actually completely based on differentiation. So, like I said, it's important to get that in mind. So, on our first point here, it says, La méthode de Lagrange. Hold on, there's a problem here. La méthode de Lagrange part de la fonction objectif à maximiser, which is our usual formula for total utility. U is equal to f of x and f of y. And la fonction contrainte à respecter, that's in terms of your budget, which is g of x and of y. It's a case where, like we said previously, this formula is equal to your revenue formula, but in this case you see that it's slightly different. Let me just increase this point. It's slightly different here in terms of the fact that it becomes your revenue formula minus your revenue formula again, because R is equal to this part here. So it's revenue minus revenue is equal to 0. Once we begin to look at graphs and how to apply this formula, you see why it is this way. But yeah, it's basically R minus R. And so the formula for Lagrange is what you see here. L is equal to L of x of y of Lagrange, le multiplicateur de Lagrange, which brings you down to this point here. F of x and y is equal to Lagrange multiplied by g of x and y. Once you break that part down, you have f of x of y plus Lagrange multiplied by what we saw here, r minus r, which is the same as r minus x times price of x plus y times price of y. So this formula here, this last formula here, is what I want you to take note of. This is your final formula for Lagrange. Okay, are we together so far? No problem. Okay, so let me break this down. The formula of Lagrange is made of two important parts. The first part is the function you're used to, which is the function of total utility, which is la fonction objective à maximiser, which means you are trying to maximize the total utility that your consumer wants to get from the goods that they're buying. So that gives you U is equal to F of X and Y. The second formula that it's made of is the budgetary constraint function, la fonction contrainte à respecter. That's to say, to respect this function, it means that you have to stay within the budget that you have. And this function is broken down into R minus R. R minus X times price of X plus Y times price of Y. And since it's R minus R, it gives you 0, which is here. Voila. So when you combine these two formulas, you have F of X and Y, which is your total utility formula, plus G of X of Y, or G of X and Y, which is the function for budgetary constraint. And then this last part, the function of budgetary constraint, is multiplied by Lagrange. We'll see how to apply that as we go on, which brings us to this final equation here, f of x and y plus Lagrange multiplied by r minus x times price of x minus y times price of y, which is the same as the function of budgetary constraint. Is that okay? Okay.
Can it be the same as?
Hold on, there's two questions. I think Xavier was speaking. And someone
No,
else.
Alex.
Alex.
Yes, that formula, that final formula, can it just end on f of xy? Because this whole thing at the end is just equal to 0.
Not entirely. It's, oh yes, okay, yes, it is equal to 0. When you multiply this times Lagrange, it will still give you 0. But you see why it's like this as we begin to apply. The thing is that you'll be using this formula to find different things. At the end of the day, it's not necessarily that this formula that you use, but rather you'll be differentiating this formula to find what you need. So this, yes, it can end on f of x and y because the remaining part is equal to 0, but you need this form to differentiate and find your formula for finding the value of y, the value of x, and the value of Lagrange at the end of everything. So it's more like a pathway to finding the value of x and of y and of Lagrange. It's not the final thing.
I get it.
Okay. Yes, someone else was speaking at the same time.
Oh yes, I was just saying, can you please run through the formula again?
Again. Okay. No problem. We have time. Before I do so, do take note of what I just mentioned, the fact that it's not your final thing, but it's just a pathway for you to find the values of x, of y, and of Lagrange. So at the end of the day, you may not have to master everything that's on top here, but just know this formula, this one that I've made big, because you will at the end of the day be differentiating it to find those values. But yes, so let's take it a bit slower again. This formula is made of two major parts. The first part is the function that you're going to maximize, the function that refers to the total utility of the goods that the consumer wants to buy. So this function, it's the same as having your total utility. It's the function that allows you to have the most utility from a good, which is f of x and y. Let's see. Voila. And then the second part of the formula is la fonction contrainte à respecter, the function of constraint that you have to stay within or that you have to respect. This function takes you back to the idea of budgetary constraint, where the consumer wants to buy goods that give them the most satisfaction, but they are constrained by their budget. They can only buy something that's within their budget. So this next formula here expresses that idea. That formula is g of x and y, which is equal to r minus x, r minus x multiplied by price of x minus y multiplied by the price of y, which at the end of the day gives you 0. And once multiplied by Lagrange also gives you 0, as was mentioned before. But we won't take note of that because what we want is to differentiate this formula. So yeah, it's just two important parts of, I guess, the entire course that we've been looking at put together, in the case where you're looking at the utility you want against the money that you have. You put them together to make one specific formula that will help you to find the exact quantity of X and Y that you want to buy. So just focus on this last part here. The rest, you'll understand it more as we go on. I hope that's to some degree clear. If not, we'll see as we go on. Is that okay?
Yes.
Okay, thank you. So like I said, if it's not that clear even now, we'll see it more as we go on. Mostly in calculations, it's better when once you see it practically, it's easier for you to understand, especially when you do it yourself. Yeah. So the last statement we have on this slide is basically explaining the idea that I just mentioned. It says la fonction L dépend de x, y et de Lagrange. Lagrange est le multiplicateur de Lagrange. So this function depends on x, y, and Lagrange, which we would differentiate this formula in order for us to have the values of all three of these things. Voila. So our next slide shows us exactly how we're going to differentiate, or what it looks like, the final result of differentiating this formula. In the first case, you are differentiating the formula of total utility in terms of, this formula of Lagrange in terms of x. So what we'll do is we'll take this so that it's clearer to see. Copy, and then we'll put it here. And we'll say L is equal to this. Voila. So our first statement tells us, well, before I continue, Alex, how much time do I have? Alex may be a bit behind in terms of network.
11 minutes.
11 minutes. Thank you, Alex. Okay. Alright. So our first statement tells us that the formula for L is at its maximum point if it meets all of these conditions. So the first condition, the necessary condition, is what we see here. There's a second condition. You will learn that in class. If I attempt to explain that here, I might confuse you a bit. So you come and learn that in your classes. 10 minutes. Alright. Okay. So in the first case, we are differentiating this formula in terms of x. So in that case, we are pretty much doing away with this y here. It's just f of x. Once you get to differentiating this formula here, you'll find that you only remain with the price of x and Lagrange. Why is that? Because we're only dealing with x here, only dealing with the part of the formula that has an x included. If we look at our R here, there's no x for us to use, so we eliminate it. We remain with a negative. In this case, we have an x. As Alex mentioned, when you have this kind of value, it doesn't show you which power it has. The power is 1. So you would take that 1, bring it down here, multiply it. So we have 1. Voila. And then the x itself will go, because it now becomes 1 minus 1, which is 0, and x to the power 0 will give you 1 again. So it's like multiplying another 1 here. And so you have this entire situation here multiplied by the price of x. In the second part of the question, we see that there is no y, so this entire part again is eliminated. Voila. So I'll come back again to this case just to go over it. We had an x here. Previously there was another value there that we eliminated, so we'll come back here. This is our entire formula: f of x of y plus Lagrange multiplied by r minus x times price of x minus y times price of y. So the first value we have to consider here is r. R has no x attached to it, and since that's the case, we removed it, and that's why we came to have negative x. The next value we had was negative x multiplied by price of x. So let me make this bigger. Script. We have x to the power 1. So what we'll do, we'll take this one and bring it down to where our x is. Multiply it. 1 there. And then what we remain with now, because we've brought this 1 down, we're going to subtract it from our x. So it will be x to the power 1 minus 1. And x to the power 1 minus 1 is the same as x to the power 0. Any value to the power 0 is equal to 1. X to the power 0 is equal to 1. And so we'll eliminate this entire thing, and we just have 1. So it becomes negative 1 multiplied by 1 multiplied by the price of x. And everything here will be multiplied by Lagrange. And that's how we came to our first condition here. F of x is equal to negative Lagrange multiplied by price of x is equal to 0. Are we together so far? Are we certain? Is that the same for everyone? If not, I may have to ask Alex to come in again, just to make sure it's understood by everyone. Okay, there's silence. I'm assuming that's okay. I do understand my limitations in some areas, so like I said, if you don't understand something, feel free to stop me. If in this case, if I see that Alex is more proficient in explaining matters of differentiation to you, I would ask him to come in to explain this part. If it's fine, we can go forward.
Can you just explain it again?
Okay, I can do so. Before I do that, Alex, do you think you understand this part of the formula, or should I do it myself? If you understand how this flows, I would request that you try to come in here and see if your friends don't understand it from you. I can try to explain it again. Do you think you'll be able to explain this part, or should I go at it again?
Just go to answer again.
Sure. Okay. So, I think I'll need to have this here a second time. so that we have a point of reference. Copy this again. Come down. Excuse me. Okay. Now is equal to this. Excuse me. Do confirm that you are able to see. I hope everything is clear.
Yes.
Yes.
Okay. Alright. So we'll start from our formula for L. This is our major formula, and this is what we'll use to differentiate and find the values of x and of y and of Lagrange. So the first thing that we'll do is we'll differentiate our formula in terms of x. So let's bring this back here, following what we have. X times price of x minus y times price of y. Wow. So at this point it looks the same as the formula on top, except we will now be differentiating in terms of x. So first thing to look at is these first values here. Put them in white. Since we'll be differentiating in terms of x, we'll eliminate the y. Y has nothing to do here. There's no way that it's involved. It becomes f prime of x because we're differentiating in terms of x, which is what we have in the first equation here. I'll put that in yellow. The next thing we have to consider is this. So for now, take Lagrange as a constant, okay? A constant in terms of the fact that it won't be affected even if we are differentiating in terms of x. It will always be there. So put this in white. Lagrange will always be there until you begin to differentiate in terms of Lagrange. The next thing to consider is the first term we have here. We have our revenue. Now, since we're differentiating in terms of x, R is on its own. It doesn't have an x attached to it. It doesn't have an x attached to it bound by multiplication, like in this case where x and the price of x are together because they are bound by multiplication. But for R, it's on its own. And since we're differentiating in terms of x, because it doesn't have an x attached to it, we'll eliminate it. It has no use here. So voila, the R is gone. The next term we're considering is this next part, negative x multiplied by price of x. I previously mentioned that x and the price of x are bound by multiplication, and that's what allows it to stay in this current state. Before we solve this part, we'll move to the next section where we have negative y multiplied by price of y. And since we are differentiating in terms of x, there is no x that is attached here, which means this entire term will be eliminated. There's no x here that's bound by multiplication or even by division. It's on its own, so we eliminate it. Voila. And so what we remain with now is negative x multiplied by price of x. And so we begin to break this down. X is to the power 1. When a value is to the power 1, it won't show. It'll just be like that. So we'll take our script just to make it clearer. So we have our x to the power 1. Voila. So now to come to the final point, we're going to begin to break this down further. To differentiate x, we'll start bringing it down. We'll take this very 1 and multiply it by x. So it will now be negative 1 multiplied by x. We'll put our 1 here. And there we go. And since we have brought the 1 down, we are going to reduce it. We're going to say x to the power 1 minus 1, which we'll have here. X to the power 1 minus 1 is the same as x to the power 0, and any value to the power 0 is equal to 1. So we have first x to the power 0. X to the power 0 is 1. So what we'll do is this entire part will go and will remain with 1. Negative 1 times 1 is the same as negative 1. And then negative 1 multiplied by price of x is negative the price of x, which will have this. That'll be our point. So what we remain with after breaking down the formula is L prime of x is equal to f prime of x plus Lagrange multiplied by negative price of x, which therefore brings us to the formula we have down here. So say this is equal to f of x plus Lagrange paste multiplied by the negative price of x. So Lagrange multiplied by negative becomes negative, and so we do away with this plus here because positive times negative is a negative. So we'll bring this negative that we have here and it will come in front because you've multiplied the positive sign and the negative sign to give you a negative, and then you have Lagrange multiplied by the price of x, which is why you have this final formula here, formula number 1. Do I need to clarify this first point?
It's clear.
Okay. Alright, so let me just take a breather. Okay. So I hope it's clear for everyone. If not, like I mentioned previously, doing a bit of revision on differentiation will help you understand everything here. In as much as I can't explain every part, doing a bit of research on your own, just like revising what you did in high school, it will help for the most part, because most of this is pretty simple. It's just understanding how to bring down powers, multiplying them, and this and that. So yeah, we'll come to this point, and what we'll do is we'll apply the same reasoning in terms of y. We differentiate now in terms of y, which will give us our second formula here. So it's the same case. You come back to the major formula of L, which is f of x and y plus Lagrange multiplied by r minus x times price of x minus y times price of y, except in this case your focus will be y. Same methodology. Since in this case what is considered to be important is your y, it will now be f prime of y. And so you come back to your formula, the very same thing. Because r isn't attached to a y, it's not bound to it by multiplication or division, r will simply be eliminated. Comme ça. But we'll bring it back, just for the sake of keeping this major part as clear as possible. The next section, this first part here, is not bound to any y by multiplication or division. It's just negative x minus negative x multiplied by price of x, but it's not attached to any y. So in that case, we eliminate this thing also because it has nothing to do with y. Which leaves us with this last point where we'll do the same method of differentiation. Because y is alone, the way it is like this, we assume it's y to the power 1. We'll bring down that power by 1, and we'll say it now becomes y to the power 1 minus 1. We'll take our script here, we have our y to the power 1, and since we've brought the 1 down, we subtract it. Minus, oh, what was that? Okay, I'll come back. So y minus 1, y to the power 1 minus 1 rather, is equal to 0, and any value to the power 0 is equal to 1. So this entire part here just becomes a 1. Negative 1 multiplied by 1 is negative 1. Multiplied by price of y is negative the price of y. Then you do your multiplication again here, and hence you have this. And then your positive multiplied by your negative will be a negative value, which brings us to our final formula here. F prime of y minus Lagrange multiplied by the price of y. So it's the same formula, the same methodology we looked at previously, except we differentiate in terms of y. The last thing we'll look at is differentiating in terms of Lagrange, which is the easiest part, because for this one you will just take your formula and eliminate everything else. So we'll take this again, copy, and bring it down here. Voila. So it comes back to this. The good thing about Lagrange is you basically eliminate everything else. For you to find this, you eliminate all of this, and you eliminate Lagrange itself. It's like the same thing. Lagrange will be to the power 1. So you bring down the 1 as usual, 1 this, and it becomes Lagrange to the power 0, which gives you a 1 again. And once you multiply it by what's left here, it just leaves you with this. So Lagrange is it's the simplest part, because you just eliminate everything and you remain with the function g of x and y, which is r minus r, which is equal to 0. And yeah, that's how you differentiate this entire part to find it in terms of x, of y, and of Lagrange. Are we okay? Okay, that we'll see in the next slide. I'll explain it a bit more, but let's focus on this part. Yeah, I'll explain it. I will explain it. Alex, how much time do I have?
All the time was depleted, madam.
D'accord. Alright, so...
We are almost in 2 minutes break.
Ah, okay. Sorry about that. Okay, so before we'll go on our break, but first let me answer the question. Then we'll come back. This will be our last break, and from then we'll be done, because the next thing we'll see here is how to apply Lagrange to the previous question we had, not the one in the exercise I gave you, but the example. So the meaning of le multiplicateur de Lagrange. The meaning of this symbol is it shows the marginal utility of your revenue. Up until this point, we've been looking at the marginal utility of our goods, but Lagrange shows you the marginal utility of your budget or of your revenue. So in the same way as we were looking at marginal utility of a good, we saw that marginal utility shows us how total utility can change once you have a supplementary unit of a good. In the same way, the marginal utility of your revenue will show you how total utility will increase once you increase your budget by a unit. For example, in terms of marginal utility, for example, you will increase the goods you have perhaps from 4 to 6, and so you now measure what your marginal utility is and how that change affects the total utility. Excuse me. Now in this case, you're going to increase your budget. For example, you had 300 and then you increase it to 301. You see how that change affects your total utility. In this example that we're going to see, we had a revenue of 240, and then we're going to increase that revenue to 241 and see how that affects the value of your total utility. So yeah, to shorten that entire statement, take note of this. The multiplicateur de Lagrange basically just signifies the marginal utility of your revenue. Instead of marginal utility of your good, it now becomes the marginal utility of your revenue. I hope that answers the question. Okay. Yeah, so we'll go on our break. Alex, you tell me when to come back and we'll finish off for today.
Can you kindly continue sharing those notes? Just trying to write something.
Yeah, I just wanted to... I just wanted to turn off my mic. These notes here, or the ones...
No, these same ones.
Okay, alright. So let me just turn off my mic and I'll come back to it. Voila.
start, madam.
Okay. Thank you, Alex. Okay, so to finish off, there's just a couple of things to note from what we've just learned. So the first statement in our next slide tells us that from the first and second functions, we come to this conclusion that f prime of x is equal to the price of x over f prime of y is equal to the price of y. Let me separate this, it's the same thing. Hold on.
Hello, madame, est-ce que vous êtes là?
Do confirm if you can hear me. Okay, sorry.
Yeah.
I don't know if previously it wasn't so clear, but yeah. Okay, so I'll start again. The first statement of our current slide tells us that from the first and second equations, that is this first one in terms of x and the second one in terms of y, we come to the conclusion that f prime of x, which is our first equation, is equal to the price of x, and f prime of y is equal to the price of y. And then it says that you can also interchange this formula by saying f prime of x over price of x is equal to f prime of y over the price of y. It's the same as equating the marginal utility of your goods by saying umx over price of x is equal to umy over price of y, and all of this gives you the value of Lagrange. So in this case, I just need you to take note of these formulas. They will become useful as we go forward. This equality here of umx over the price of x is equal to umy over the price of y is equal to Lagrange it proves the second law of Gaussian. I mentioned at the beginning of this section that we would still be reasoning from the second law of Gaussian. And so we saw that even in the previous one, the previous lesson, how that application still came back to the second law of Gaussian, which is the law of weighted marginal utilities. So even in this case, it still comes back to that law. And then, like I mentioned previously, in answer to the question that was asked, the last statement we have here says le multiplicateur de Lagrange, Lagrange, signifie l'utilité marginale du revenu, indique l'accroissement de l'utilité totale lorsqu'on augmente le budget d'une unité monétaire. So, it signifies the marginal utility of our revenue. It indicates how the total utility increases when we increase our budget by 1 unit. For example, you say 240 to 241. We see how our total utility will change once we increase our budget from 240 to 241. I hope that's clear. Okay, you're a bit low, but I think I got the question properly. So to prove this point, we will take this first one here. Okay, we copy. So the first statement tells us that this is it's a deduction. We deduce. So it's not something that's shown exactly, but we kind of just assume the situation. So for the first point, for us to come to this conclusion that f prime of x is equal to price of x, what we'll do is that we'll move this entire thing here, negative Lagrange multiplied by price of x, to the other side where 0 is, so that it becomes a positive. So we'll cut this and it will come here. Voila. and so because we've moved it to this side, it becomes a positive now. And in the same way, for f of y, let's say f of y, we'll get the same formula here. Hold on. Voila. We'll get this formula here. Copy. So we're running out of time, but if I exceed, I'll ask for about 10 minutes more of your time, just so we can finish this part here. So yeah, in the same way, we would take this part of the formula. Basically, we're making f prime of x and f prime of y the subject of our formula. So we'll cut this, bring it to where 0 is, so it becomes a positive value. Voila. Remove this negative here. So since at this point we don't necessarily know the value of Lagrange, we deduce. It's not an exact thing, but we assume that f prime of x is just equal to the price of x, and f prime of y is just equal to the price of y. It's like we're ignoring that Lagrange is there. We know it's there, but we just assume for the moment that this is the equality we have. So it's just a sort of assumption for the moment. I hope that answers the question. Okay. All right. Before I go on, are there any more questions? Any clarifications needed? Okay.
Clear.
All right. Thank you. Okay. So the last important thing to take note of on this particular part is this last part here, where umx over the price of x is equal to umy over the price of y is equal to Lagrange. I'll need you to take note of this point here very well, because we will see it later. We'll have to prove it actually at the end of our calculations. So that's one important thing to take note of from this point. Okay, then we go forward. So now we are going to try to apply what we've learned. This is something we had in our previous lesson, in lesson 5. We applied this exact question. So let me just bring up lesson 5, just for us to go through what we did real quick. We'll come down again. Alright, so when we first began to apply TMS, we used the first method where we were talking about using the price of our goods to make a ratio and then find the answer. So in this case, our revenue was 240 and the prices of goods were 1 and 2. So we applied our TMS using the goods, the prices of the goods, to have our ratio 2/4, which gave us in the end 1/2. Let me increase this. 24. And we came up with this equality: x is equal to 2y, and we replaced it in our equation for revenue, and that's how we found the value of x and y. In this case, y was equal to 30 and x was equal to 60, and I gave you a few steps to follow just to verify that. So now we're going to use the formula of Lagrange to find the very same answer. We're going to solve the same question. So now what we'll do is we'll take the values of our revenue here, the value of our price of x here, and the value of our price of y, and we will replace them in each of the formulas that we made. So first thing we'll do is we'll take the first the first major equation that we have. So come back here. Let's see, this is it. LXY, not this one. Just a moment, let me find this major thing. Voila. So we're going to take our formula once again. We'll copy it. Come down here. So put it right here so we can see how everything works. There. Let me say L is equal to this. So when we begin to replace our values in our formula, we'll first take our revenue and put it here where our R is. We have 240. And then we have the price of X, which is 2. We'll put it here, 2. And the price of Y, which is 4. We'll put it here, which will in turn give us 2X minus 4Y. In this case. So for our formula for f of x and y, we'll go back to our question, which is in lesson 5. We'll come to our question here. So in our first question, it gave us a unique formula for total utility. Remember what I mentioned previously, that for every question that you have, you'll be given a specific formula for total utility. And in this question that we had previously, our formula was u is equal to f of x and y is equal to x times y. So always take note of this, knowing that our formula for f of x and y is x times y. It's what we're going to have in this case, where it's now just been reduced to x times y. This entire thing here is just equal to x times y. Are we together so far? Let me clarify it here. Just put it here. F of x and y is equal to x multiplied by y. Voila. And so we'll take that and we'll replace it here in our formula. X times y. And so once you break down this entire thing, it then gives you the first equation we have down here, which is L is equal to x times y plus Lagrange multiplied by 240 minus 2x minus 4y. This is our first major equation. And so we'll use the same reasoning we looked at previously to break down this formula. We're now going to begin to differentiate. So first we differentiate in terms of x. As usual, the first term we look at here is x multiplied by y. In this case, our x and our y are bound by multiplication. That means you would take the 1, because x to the power 1, you bring it down and multiply it by this. Voila, you have 1. And then it then becomes x to the power 1 minus 1, which is equal to 0. And then x to the power 0 is just 1 again. So come down here and we have 1. 1 times 1 is 1, and 1 times y is y, which is why we have this first y here. We'll put that in yellow. Then we begin to break this down again. Like I said previously, pretty much just ignore Lagrange for now, because it won't be affected. In any case, it's bound to this entire thing by multiplication. So even if outside of the bracket it doesn't show any x, it's bound to the entire thing by multiplication, and so it will still always remain there. The first thing we have to look at is our revenue. as we mentioned before. The revenue is not bound to x by any form, whether multiplication or division, so it would just be eliminated. Voila. You remain with negative 2x. Use the same formula, the same methodology. Bring down the power of x, it becomes 1 times negative 2, and it becomes x to the power 1 minus 1, which is x to the power 0, which is the same as 1, which means what you remain with is just negative 1 multiplied by 2. I'll show that here. 1 multiplied by 2, the x is now gone, and so you remain with negative 2. The next term to look at is 4 multiplied by y, but since this 4 doesn't have any x that's bound to by multiplication or division, it's just eliminated as well. We'll do so, and so we remain with this point. Negative 1 times 2 is negative 2. Negative 2 multiplied by Lagrange becomes negative 2 times Lagrange. We'll eliminate that, cut this, put it here, and that's what brings you to our final first equation here. Because the negative, remove that, it becomes y minus 2 Lagrange, and this is always equal to 0. So yeah, basically we're applying the same matter of differentiation, power x. Is that okay? Okay, we are doing differentiation in this case because
Yes.
thank you, we are assuming that it hasn't been done yet. What we've done in this case, the first point we had, let me just make this a bullet point. Voila. This first point we had here, we first began by replacing our values for revenue, for the price of x and the price of y in the original equation, the very first equation, which we had, so as to now begin to differentiate. It's like you come back to, which point is that? It's like you come back to this point here, you begin to replace the values, and then after you replace the values, you begin to differentiate. So it's like you haven't done the differentiation yet. You first put in the values and then you differentiate, and that's why we're doing that here. I hope that answers the question. Okay, right, so the next thing you do is you will apply the same rule now in terms of x. So you will differentiate this major formula that we've created here by replacing in the values in terms of x. In the same way that we did for y, since x and y are bound by multiplication, you will say y to the power 1, bring down the 1, multiply it there, y to the power 1 minus 1 is 0, which is equal to 1. So 1 times x is just x. And then when you come down to this part, you eliminate everything that has nothing to do with y. The first part is 240. There's no y that's bound to it. You eliminate it. The next part will be x times price of x. X times price of x has nothing to do with y. You eliminate it. The next thing you're going to have then is negative y times the price of y, and you do your differentiation again, which will eventually bring you to the point of having 4 multiplied by Lagrange. So let me bring down this formula again, or in this case it brings you to your next equation, f of y minus Lagrange times the price of y. the price of y in this case is 4 multiplied by Lagrange, which gives you 4 Lagrange, and everything is equal to 0 again. Like I said previously, when you now begin to differentiate in terms of Lagrange itself, it becomes pretty easy because you eliminate everything else and you remain with one thing. So what we'll do is we'll remove this for now and bring back our major equation, which is this here. Copy that. And paste that here. L is equal to this. Do the same thing we did and replace our values here. Because you're differentiating in terms of Lagrange, f of x or f of y has nothing to do with Lagrange. What you have here is x times y. X times y. But this part has nothing to do with Lagrange, so you eliminate it. You remain with Lagrange. Once you differentiate Lagrange is to the power 1. You bring down the 1. You remain with Lagrange to the power 1 minus 1, which gives you 0. Lagrange to the power 0 is 1 again. So 1 times everything else here, we'd say Lagrange becomes a 1. 1 times everything else here is just the same thing. So basically you remain with this formula here. And by now, of course, we would have already replaced the values. R is 240. We don't know x, but we do know the price of x. The price of x is 2. So that at the end of everything gives us 2x. And we know that the price of y is 4. So that at the end gives us 4y. Which is how we end up with this final equation down here. And once again, everything is equal to 0. And yeah, so that's basically how you apply differentiation and replacement of values in this case here. So now you have 3 formulas. In the previous slide, we saw that from the first and second formula, we deduced that f prime of x over f prime of y is equal to the price of x and the price of y. So for us to finally find the values of x and y, we're going to use that equality and replace it. The next point is this here. From 1 and 2, we deduce that y over x is equal to 1 over 2. That's to say that x is equal to 2 multiplied by y. And so I broke it down here so we can see just what that means. So we'll take our first formula. The first formula we have here is y minus 2 Lagrange is equal to 0. We'll place it here. And the next formula we have is x minus 4 Lagrange is equal to 0. So what we'll do is we will take this part here and take it to the side where we have 0 so that y becomes the subject of the formula. Voila. And we'll do the same for x. We will take our negative 4 Lagrange to the side where we have 0 so that x becomes the subject of the formula. Let me separate this. Refusing to highlight. There we go. So we take it to the side where we have 0, and x becomes the subject of our formula to the point where we have y is equal to 2 Lagrange and x is equal to 4 Lagrange. So we are going to put this together in a way where we find the value of x and y. The first thing we have to do is make Lagrange the subject of our formula. So we'll take our first equality, which is y is equal to 2 Lagrange, and we'll divide both sides by 2. Y divided by 2 is just y divided by 2, and then 2 Lagrange divided by 2 will give you Lagrange. In the same way, we'll divide both sides of x by 4. So 4 Lagrange divided by 4 is just Lagrange, and then we have x divided by 4. So we have two different formulas here that give us the value of Lagrange. The first one is y over 2, and the other one is x over 4. And this is still in keeping with what we saw previously. Let me go up a bit. In this case, where this formula here will give you Lagrange in the same way. Lagrange is equal to y over 2 is equal to x over 4. In the next slide, we'll see how to apply this point here for marginal utility. But for now, just keep this in mind and follow along with me. The next point is the fact that Lagrange being equal to these two formulas will equate them. We'll now say y is equal to 2 is equal to y over 2 is equal to x over 4, because they both give us Lagrange. When you cross multiply these two, it gives you 2x is equal to 4y. Divide by 2, it gives you x is equal to 2y, which is the same thing we found when we used TMS, which is this case here. X is equal to 2y. So I've run out of time. I just want to show you the answer, and then I'll send you this PowerPoint, of course, and you'll be able to go over everything yourselves. Okay? And I'll recommend a couple of videos on differentiation just for you to get the grasp of everything. So the next part is pretty straightforward, the very same thing we did previously. We'll get this equality of x is equal to 2y, and we will now replace it in our formula for revenue, where revenue is equal to x multiplied by the price of x and y multiplied by the price of y. So our formula came to 2x plus 4y. Since x is equal to 2y, we'll put that 2y there, multiply it. We now have 240 is equal to 4y plus 4y, which gives us 8y. Divide that by 8, it gives you the value of 30. And since x is equal to 2y, we say 2 times 30 is equal to 60, which are the very same values we found in the previous application. What we'll do is we'll get these values of x and y, replace them in our formula for total utility, and it gives us 1,800, which is the same answer we found even in this case in step 3. And finally, we'll try to find the value of Lagrange, which is y over 2 is equal to x over 4. Y over 2 is 30 over 2, and 60 over 40 is x over 4, which gives us the same value of 15. And that's pretty much how we apply this last part. We don't have time, but we have one more slide. Are we together? Okay. Yeah, I figured as much. I was going a bit quickly. So, because I've elapsed my time, what we'll do is, in our next lesson, we'll come and we'll run through this part quickly again. Our next lesson is tomorrow, of course, so it won't be so much time. So we'll begin our next lesson by going through this application again. But I'll send you this PowerPoint, and I'll request that you go over it and just try to deduce things for yourselves. We'll look at it together first thing tomorrow morning, and then we will finish our lessons. I'm assuming everyone is tired, as I'm also tired, so we won't try to go over this last slide. It's also a bit complicated on its own, so it will be our ending point for the next lesson. So yeah, that ends our lesson for today. Thank you for attending. Whatever questions you have today, feel free to ask in my DM. But of course, we will go over this lesson again, this last part of the lesson again tomorrow morning, and finish off this section. So yeah, that ends our lesson for today. Thank you so much, and have a good rest of your day. Thank you.